Let's start anyway. Let us do multiple sharing of screen and see what happens. Are you able to see? I think you can see now. Sandhya also joined. Okay. Very good, Sandhya. Sandhya, good, you did the homework. All the sums are right. But how the steps you did in the sums only, I am wondering. Okay. Your answers are all right. But the steps, how you did it, I am wondering for some of the sums. Because some of the steps are wrong, but you are getting right answer at the end. That is not possible, no? So I'm wondering what you are actually doing. Okay, I was just telling what is association property. When we have three sets, A, B, and C, then bracket of A intersection B, close bracket intersection C, is if it is equal to A intersection open bracket B intersection C. Okay, so if that is the case, then there is a association of intersection. Association property of intersection is true. Same way, if A union B, A bracket open A union B close bracket union C is equal to A union open bracket B union C close bracket. Okay, then that is the associative property of where we have that example. This one is that example. Can you see this one in blue? I have highlighted. In that case, this is association property for union. Association property is true for union of three sets. Okay, like that. Now, for differences of set, you never have truth in either commutative property also won't be true, and which one? Associative property also won't be true for what? For commutative, associative, and properties. What will not be true? Set differences won't be true. A minus B is not equal to B minus A. Okay. So don't think this is not commutative, not commutative. What is not commutative? Set difference. Set difference is not commutative. Same way, A minus B minus C is not equal to A minus B minus C. So it's not associative also. Set difference is not associative also. Okay, but in some cases A minus B equal to B minus A. When A is equal to B, when A is equal to B, then it becomes A minus A is equal to B minus B. That means null set is equal to null set, which is always true. Okay, so when A is equal to B, then only A minus B equal to B minus A, only in a special case. Okay, but generally set difference is not commutative, set difference is not associative. Only union and intersection are both commutative and associated. Okay, now let us go on to the new thing that we want to do. Okay, distribution and Demorgan's law we should do now. Exercise 1.4 we finished in class Arpana. I will send you the link. I'll put it on YouTube and send you the link. Okay, then you can see that. Now let us do distributive property. In lower classes we have studied distributive property of multiplication over addition. How is distributive property of multiplication over addition? That means like this. Multiplication is at the front. Okay, addition is the next. Okay, addition is within the brackets. Multiplication is outside. Multiplication is, so this becomes A into B plus A into C. Okay, so what happens? Multiplication over addition is distributed. So when you distribute, first A into B plus A into C you will get. Okay, so 2 times you will get the multiplication when you finally do it. Okay, so that is the distributive property of something over something. Okay, The multiplication over addition means multiplication will come first. Now, in set operations, we don't have multiplication, addition like that. We have union, intersection like that only, correct? So, what you must do is you have to think about distributive property of union and intersection. Okay. Now, take any three sets A, B, and C. Okay. Now, what is the first thing telling? Here, what is outside? This is intersection, correct? What is inside? Union. So this is the distributive property of intersection over union. Intersection over union. Okay. What will happen? A intersection B, union A intersection C. Just like A into B plus C is equal to A into B plus A into C. A into B plus A into C. So same way, A intersection B union C is equal to A intersection B union A intersection C. Okay, very simple. If you have any doubt on how the formula is arrived, you just do A into B plus C and find out. Okay, same way, this is union. This is intersection. So, distribution of union over intersection. Okay. So, that also means A union B intersection A union C. Okay. That is how it will come. So, this A union B will come double times. Okay. And this will come only in the middle like that. Okay. So, it's like saying this operation I am doing on this and doing on this. A union B and A union C. And the intersection is coming only once. Okay. Now let us do an example, then it will be clarified very clearly. A is equal to 0, 2, 4, 6, 8. Okay, all even numbers, whole numbers up to 8. Then B is equal to X such that X is a prime number and X is less than 11. So X is 2, 3. What else? What else, guys? Sound of silence.
Could you repeat the question, Uncle?
X is such that X is a prime number and X is less than 11. What is the set P?
2, 3, 5, 7.
3, 5, 7. Yes. Because it's less than 11, it's not less than or equal to 11.
Yes.
Okay, so very good. 2, 3, 5, 7, 0, 2, 4, 6, 8. Okay. Now, and C is also given in set builder notation. Such that X is a natural number. Okay. And X is greater than or equal to 5 and less than 9. Natural number, greater than or equal to 5. What is C then? Greater than or equal to 5. That means it equals 5. Then
6, 7, 8.
very good. Very good, Sandhya. 6, 7, and 8. Okay, C is equal to 5, 6, 7, and 8. Now you have this thing. Now he's asking, verify the distribution law of union over intersection. Why am I telling union over intersection? Because union is first, intersection is inside the bracket second. Okay, that is why. Okay, that means A union B, then A union C will be there, and intersection will join them. See, A union B and A union C will be there, and this intersection will join them. Okay, in the middle, like that. Okay. So given A is equal to 0, 2, 4, 6, 8, B is equal to 2, 3, 5, 7, you said correctly. C is equal to 5, 6, 7, 8, that also you said correctly. Okay. First, what you should find, clear everything. First, what you should find? B intersection C you should find. Okay, what is B intersection C? B intersection C. What is that? This is a common result. What is that? Tell me. Tell me, guys. Anyone tell me what is B intersection C? What is common to B and C?
7, 5, Uncle.
5. Okay. 2 and 3 is not there. 7. Okay. Then that's all. B intersection C. That's all. Okay. So this is B intersection C. Then A union B intersection C. What is that? 0, 2, 4, 6, 8 union 5, 7. Now what is that? You tell me. Anybody tell me? Arpana, tell me. What is the union of these two?
Nothing. It is 0, 2, 4, 5, 6, 7, 8.
Correct. Very good. Okay. So this is also done. Okay. You don't look at that other one. You can just go on in our mental calculations. Very important that the more sums you work out, the more faster and confident you will be in doing. Okay. So this is the left hand side. Now we have to work out. Let us go and instead do this in the. Let us do this. 0, 2, 4, 5, 6, 7, 8. That's all 11th standard operations research mathematics. When you come to 11th standard, very interesting. Network diagramming for project scheduling. Very important. So what we found out here, A union B intersection C is equal to 0, 2, 4, 5, 6, 7, 8. Okay. Now what you have to do, you have to find A union B intersection A union C. Okay. Let us first find A union B. What is A? Okay, what is A union B? A is and B is. Okay, what is A union B now? Somebody tell me. Yeah.
2,
Huh? A union B.
2, 3, 4, 5, 6, 7, 8.
A union B. Okay. Now let us do A union C. C is what? C is equal to 5, 6, 7, 8. Okay. A union C is what now? Arpana, tell me. A union C.
Union C, uncle.
A union C.
0,
A union C.
0, 2, 4, 5, 6, 7, 8.
Very good. Okay, A union C. Now, intersection of these two. Intersection of these two. What is common between these two? This common, 0 common. Somebody tell. Yes, Sandhya.
Yes, uncle.
0, then
2,
okay,
4,
okay.
5, 6, 7, 8.
Okay, so this is A union B intersection A union C. Okay. Now what we found, first one 0 to 4, 5, 6, 7, 8. 0 to 4, 5, 6, 7, 8. So both are equal. Left hand side is equal to right hand side. So we have proved the distributive law. A union B intersection C is equal to A union B. Okay, this is first time. A union B intersection. This is second one. A union C. Okay, this operator must be applied all the time. This operator must be applied only in the middle. Okay, so you have proved that. Okay, very good. Let us do it with the Venn diagram verification. Venn diagram verification, you have to do the steps. You simply cannot give the final diagram. Verify A intersection B union C is equal to A intersection B union A intersection C. Okay, using Venn diagram. Okay. First, LHS, left hand side. Okay, left hand side. B union C is first thing you have to do. Okay, what is B union C? This whole thing is B union C. Correct, this whole thing is B union C. Very good. Then A intersection B union C. A is intersecting with this thing here. Only this part of it is A intersecting. Okay, so you are correct. This part is A intersection B union C. Very correct. Okay, so left hand side is coming like this. Now you have to do right hand side. First thing you have to do is A intersection B. Okay, what is A intersection B? This one is A intersection B. Very good. Then A intersection C. What is A intersection C? A and C are here. So this one is A intersection C. Okay. Now he is telling you have to find the union of these two. This plus this. Okay. So that becomes again this plus this. So this is a result. Same result? No, same result. Yes. Same shape is coming both ways. Okay. This is 1, this is 2. So both are same. Like that. Okay, when you have A intersection B and A intersection C, then the final union. This is step 1, this is step 2, and this is step 3. You simply cannot put this last diagram and tell that you have proved. I will put 0 mark. Your teacher will put 0 mark. You have to give step 1, step 2, and then step 3. Here there are 2 steps here. Okay, one is B union C, step 1. Then A intersection B union C, step 2. Always what is in bracket will be step 1. Okay. That way. So here there are 2 steps. So simply putting final answer and telling that see, if you draw only this diagram, and say it is equal to this diagram and draw again the same diagram, okay, 0 marks, 0 out of 10. Okay, whatever, 5, no marks. Okay, Sanjay, you understood? You should not put like that. You should actually give the steps. That is where the visual reasoning is coming in, so that we know that you know what you are doing. Simply giving the final steps, we can also copy or do something, and all kinds of things can be done. Huh? Okay, so that is verified. Now let us go to a very interesting, but finally something more interesting. Something more interesting, and you have to think now. First time you have to think. Okay, Demorgan's laws. And they are telling, no, this guy is born in Tamil Nadu, in Madurai. It's a British mathematician, but he's born in Tamil Nadu. Very interesting. 1806, that means more than 215 years ago he was born. Okay. So see, imagine 215 years ago you found out all this, and now only we are studying, and we are finding it very nice to study. His father was posted in India by the East India Company. You know what the East India Company is? History you have read, right? Yeah. When he was 7 months old, his family moved back to England. So Demorgan was educated at Trinity College, Cambridge, London. Okay. Very high college. Cambridge and Oxford are the 2 greatest universities in England. You know that, right? Oxford is number 1, Cambridge is number 2, or whatever. Oxford and Cambridge. Number 1 and number 2 universities you want to study in, right? Yeah, very expensive universities to study in also. Okay, Demorgan law for set difference, he has come up with some law. Okay, these laws relate the set operations, union, intersection, and set difference. Okay, usually we are doing this separately. We don't usually link up the A union B. We don't link up with A minus B, okay, or A intersection B. Also we don't link up with this, but this guy is linking up all these things. So a very interesting way he is linking up. Let us see how he is linking up. Consider 3 sets A, B, and C. A is equal to -5, -2, 1, and 3. B is equal to -3, 2, 0, 3, and 5. C is equal to -2, 1, 0, 4, and 5. Okay. Now what is doing? Let us see what is doing. First is making B union C. B union C. Okay. -3, -2. Okay. -2 is here common. Then -1 is here. Okay. -1 is coming. Then 0 is here. 0 is here common. 0 is coming. Okay. Then 3 is here. Is putting 3 here. Okay. Then 4 and 5 are here. Then 4 and 5 are there. But 5 is common, so leave out that. So B union C is correct. Correct. Okay. Now he's doing a very interesting thing. Usually what you will do? You will do A union B intersection C, that is distributive law and all of that you do. Now he's doing a very different thing. He's putting minus and combining that with union operation. Set difference operation is combined with union operation. Okay. A minus B union C. Okay. So this is B union C and this is A. Okay. A is -5, -2, 1 and 3. -5, -2, 1 and 3. And B union C is -3, -2, 1, 0, 3, 4 and 5. Okay. A is -5, -2, 1, 3. Now from A you have to minus all this. What do you minus? -5 is there, so you take -5. Okay. -2, -2 will go off. Okay. 1 is there. No, there is no 1 here. 3 is there. 3 will go up. Okay. So what is remaining? -5 and 1 only is remaining. Correct. This is correct. A minus B union C is equal to -5 and 1. Okay. Then he is doing something else. Okay. He is now going and finding out A minus B and A minus C. Okay. Let us do A minus B and A minus C. A minus B. Okay. What is A minus B? A will have -5. Okay. It's not found there. So -5 is there. -2, -2 is there. It will go cancel off. 1 is here. There is no 1 there. So 1 is there. So -5, 1 is there. A minus B. 1 is there. Then 3 is there. 3 is there. Both places 3 also will go. So A minus B is -5, 1. Correct. This is correct. Then let us try A minus C. A minus C will be what? A minus C, let us try. So A is -5 is there. Okay, no -5 in C. Okay, no -5 in C. -2 is there, -2 is there. So cut this off. 1 is there, no 1 is there in C. So retain that. Okay. Then 3 is there, no 3 is there. So 3 you can keep. Okay. So A minus C is equal to -5, 1, 3. Correct. This is also correct. This is also correct. Now he is doing interesting thing. A minus B union C he did first. Now he is doing A minus B union A minus C. Okay. He's sort of using distribution for subtraction. Okay. For subtraction. Okay, is using that, meaning for difference. In subtraction in set theory is called difference. This is A minus B union A minus C. Okay, so A minus B union A minus C is -5, -1, -5, -1, 3. So it means okay. This is union. That is correct. Okay, and then he is telling another law: A minus B intersection A minus C. Okay, that will be this one. This one. Okay, -5, -1. Very good. Now, what is he coming to conclude? What is he coming to conclude? He is concluding that A minus B union C is not equal to A minus B union A minus C. Okay, that means this distributive law is not true. Okay, usually what we do, A intersection B union C is equal to A intersection B union A intersection C. Okay, this is distributive law, where of intersection over union. But here is telling of difference over union is not true. A minus B union A minus C is not true. It's not equal to. Okay. That is what he's telling. Okay. So that is a very important conclusion that we are arriving at. But from 1 and 3, something else is arriving at. Okay. A minus B union C is equal to A minus B intersection A minus C. Okay. This is a very funny thing. Okay. A minus B union. So distribution of set difference over union, okay, is not coming to this correct. It's not coming like this, but the inverse function is coming. Intersection function is coming as true. See how it is true. A minus B union C is what? This one. Minus 5, 1. Okay. Then A minus B intersection A minus C is what? Again minus 5, 1. So these two are equal. Therefore, A minus B union C is equal to A minus B intersection A minus C. Okay, not union A minus C. So very important finding that is done. Okay. So remember that one. What you have to say? A minus B union C is equal to A minus B. Okay. Then A minus C, both you put, but instead of putting union, you say intersection. Okay, you put the ulta there. Then you get one of the answers. Okay. Okay, let us go further. Some more things we have to discover. Now, B intersection C is another thing is now taking. Union C now you are putting. Now is saying B intersection C. Okay. What is B intersection C? Okay. B is minus 3, minus 2, 0, 3, 5. And C is minus 2, minus 1, 0, 4, and 5. So what will be B intersection C? What is common? This is common. So minus 2 is there. Then 0 and 0 is common. So 0 is there. Then 5 and 5 is common. So 5 is there. This is correct. B intersection C is minus 2, 0, 5. Okay. Now he is telling A minus B intersection C. First time he did A minus B union C. This time he is doing A minus B intersection C. What is A? A is okay. So A minus B intersection C. So minus 5, that will be equal to minus 5 is there because there is no minus 5 in B intersection C. Minus 2 will cancel. 1 is there, no 1 is here, that will be there. 3 is there, no 3 is there. Okay, so this is correct. A minus B intersection C. Okay, now you take that. Now what you see, A intersection B, A minus B intersection A minus C was minus 5, 1. Okay, so he derived one law, which is this law. He derived one law, A minus B union C is equal to A minus B intersection A minus C. Now he's deriving another law. A minus B union C is saying is not equal to A minus B intersection A minus C. Because A minus B intersection A minus C is what? Minus 5, 1. What is this one? This one is minus 5, 1, 3. Okay, so this is not equal to this. Not equal to. Okay, so A minus B intersection C not equal to A minus B intersection A minus C. Okay, so not equal to. Instead, we note that what is A minus B intersection C? Minus 5, 1, 3. If you go upward, it is equal to A minus B union A minus C. Okay, so A minus B intersection C is equal to A minus B union A minus C. Ulta again. Okay, this place you are getting intersection. This place you are getting union, but something like distribution law. Okay, so this is the paradox of the whole thing. Okay. Can we write it again? Demorgan's law for any sets 3 A, B, and C. A minus B union C will be A minus B intersection A minus C. Okay, A minus B intersection A minus C. For any 3 sets A, B, and C, A minus B intersection C will be A minus C union A minus B union A minus C. A minus B union A minus C. Okay, that is the whole thing. Just like distributive law, but ulta. Intersection will become union and union will become intersection. Okay, that is very important to remember. You have done a very important thing now, and Demorgan's law, very important discovery. Okay, now you have to do Venn diagram again. Sandhya, when you do Venn diagram, you have to do each step one by one. Okay, simply drawing the final diagram and telling you are giving only the proof, that is not proof, you will get 0. Okay, you want to get 0, you do that. But if you want to get marks, you do each step by step and show and prove, okay, that you understood the problem and you are actually solving the problem. Okay, what is the first step? First step is B union C. Okay, left hand side, first step is B union C. You must find out. What is B union C? This is B and this is C, both coming together. Okay, this whole area is B union C. Correct? Okay. Then A minus B union C. From A, you should minus this whole thing. What all will go off? This whole thing will go off. Okay. What will remain? Only this part will remain. Okay, it's correct. A minus B union C. Okay. This is step 1. First, left hand side, LHS is come like that. Now what you have to do, this first step, this is second step. You understand? This is first step, this is second step. Don't simply put this diagram and tell that I have got it. No, you have to tell how you got it. How you got it? You have to prove. Okay. LHS over. Now you got to go to the right hand side. Right hand side, this is the first step you have to do. This is the second step you have to do. And combine this intersection will be the third step you have to do. Okay, 3 steps you have to do. Okay, first A minus B. This whole thing is A. From that, if you subtract B, what will happen? Take away B, only this thing is left. Okay, so that is left. So from A, you subtract B, this is left. This area is left. Okay, that is A minus B. That is first step. Then second step is A minus C. From A, you subtract all that is C. Take this off. Then what will be left? This will be left. Okay. So this will be left. This is second step. Now what you have to do? You have to do an intersection. What is common between these two? What is common between these two? This part is coming only here. This part is coming only here. But this part, okay, is coming in both the section. That is why this part is your answer. Okay. This is only the intersection, the commonality between both these things. Now you see that left hand side was also like this. Right hand side also the same thing. Therefore, LHS equal to RHS. Okay. Therefore, A minus B union C is equal to A minus B intersection A minus C. Okay. This is the first Demorgan law has been proved. Okay. This is proof by Venn diagrams. This is proof by Venn diagrams, not by using sets. Now you are going to get some complicated thing now. Okay. Set builder notation is given. Who will tell me what is P? P is X such that X is a whole number and X is greater than 0 and less than 10. What is the values of P then?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Excellent, Sandhya. Very good. Okay. Q is also given in set builder notation. Okay. Q is such that is the member is X such that X is equal to 2n plus 1, while n is a whole number and n is less than 5. So what is n here? What are all the values of n? N is whole number. What are all the values of n? Arpana, can you tell me? Values of n? N is a whole number less than 5.
Less than 5. 0, 1, 2, 3, 4, uncle.
Very good. Excellent. Now, this is not the set. N is a whole number, n is less than 5. But x is what? 2n plus 1. Okay. So, n is, this is n. N is equal to 0. What is 2n plus 1? 2 into 0 plus 1 is how much? 2 into 0 plus 1. How much?
1, uncle.
Very good. Same way, 2 into 1 plus 1. How much?
3.
Very good. Then 2 into 2 plus 1. How much?
5.
Very good. Then 2 into 3 plus 1.
7.
Okay. Then 2 into 4 plus 1. How much?
9.
Very good. So you got Q, you got P. Okay. Now, very good. So, is he got the thing correct? 1, 3, 5. Okay. 1, 3, 5, 7, 9. Now you know how we got that. 1, 3, 5, 7, 9. Okay. Very good. R is equal to 2, 3, 5, 7, 11, 13. That is easy. Okay. You know directly. Now verify that P minus Q intersection R is equal to P minus Q union P minus R. Okay, that is what this is the other Demorgan's law. Okay, this is the intersection based law. You have to prove now. Now, this is not using Venn diagram. This is using actual numbers. Okay. So, what do you have to first find? First, you have to find this Q intersection R. What is Q intersection R? Q intersection R. Or we will take and do it in our screen. Oh, I have to rub this also off. Okay. So roster form, you are getting A is equal to 1, 2, 3, 4, 5. And Q is equal to 1, 3, 5, 7, 9. And then R is equal to 1, 2, 3, 5, 7, 2, 3, 5, 7, 11, 13. Now what you have to do? Prove P minus Q intersection R will be equal to P minus Q union P minus R. That's what it is. Demorgan's law. Second Demorgan's law. Okay. First thing what you have to do, Q intersection R you have to find. Okay, tell me what is Q intersection R? Anybody? Arpana, tell me. Q intersection R.
Q intersection R, uncle. 3, 5, and 7.
3, 5, 7. Very good. Okay. Now P minus 3, 5, 7. What is P minus 3, 5, 7? This is P. P minus 3, 5, 7. How much is there? What is the answer? Or you can even write it 1, 2, 3, 4, 5, 6, 7, 8, 9 minus 3, 5, 7. How much? Sandhya, tell me.
1, 2, 4, 6, 8, 9.
Very good. So this is LHS. Okay, this is LHS. Now you have to do right hand side. This is RFH here. Now first do P minus Q. What is P minus Q? 1, 2, 3, 4, 5, 6, 7, 8, 9 minus 1, 3, 5, 7, 9. Arpana, you tell me what is P minus Q?
Q is 1, 2, 4, 6, 8, 9.
P minus Q. 1 and 1 are there. So this will cancel out.
Oh, sorry, uncle. 2, 4, 5, 6.
No, 5 and 5 are there.
I'm
Will
sorry.
cancel out.
1,
2, 4.
4, 6.
Okay.
And 8.
Yes, P minus Q. Okay, Sandhya, you tell P minus R.
1,
Okay.
4,
Okay.
6,
Very good.
8, 9, 11, 13.
No. 11, 13 is in R. It's not found here. 11 and 13 is in R. Huh? It is not found here. So only from P you have to minus R. Okay. So only 8 and 9 will be there. Where is 11 and 13 here? There is no 11 and 13 here. Correct? So you guys are getting confused now and then. This is not the set. This is not the set. These two elements are not there. So how do you minus? You have to see if this is there in the second set you are minusing. If this is uniquely present here, then you put it there. Okay. If this is found in the other one, you cancel it out. Okay. That is why 1 is uniquely present. So you put 1. 2 is found here. So you cancel 2. Okay. 3 is also found. You cancel 3. Like that, 8 is found. No, 8 is not found. So you added 8. 9 is found. No, 9 is not found. Added 8. Afterwards, nothing is there. Where is 11 and 13 coming? It should not come. Okay. That's all. Because it is P minus Q. Okay. When you do R minus P, then you can talk about 11 and 13. Now what you have to do? These two union of these two. What is the union of these two? Sorry.
2, 4, 6, 8, 9.
What about this one? That is 1.
Okay, uncle.
1. Okay, 1. Then 2, 4. Okay, then 6, 8,
8, 9.
9. Okay, this is RHS. Is left hand side equal to right hand side? 1, 2, 4, 6, 8, 9. 1, 2, 4, 6, 8, 9. Yes. LHS equal to RHS. Therefore, P minus Q intersection R is equal to P minus Q union P minus R. So Demorgan's law, second law is also proved. Okay. This proof is by actual sets. The former proof was by Venn diagrams. Okay. Now let us go for some more advanced things. Let me just paste this here. Okay. Demorgan's laws for complementation. Something other than that two Demorgan's laws, you are also having laws for complementation. Okay. These laws relate the set operations on union, intersection, and complementation. What were the first set of laws doing? Union, intersection, and difference. Okay. First set, what it did? Union, intersection, and difference. Okay. A minus B union C is equal to A minus B intersection A minus C. Same way, A minus B intersection C is equal to A minus B union A minus C. Okay. So this was all about difference. Minus, minus, everywhere minus, difference. Now he is going to give some laws for complementary. Okay. Let us try to understand this one also. And I think with that we should end our session today. Okay. We cannot do the exercises. Exercise we do tomorrow. Because these are very important things. These laws relate to complementation. So let us consider the universal set. As soon as complement comes, means what will come? A complement means what? Universal set minus A. Correct. So immediately universal set will come. So universal set is 0, 1, 2, 3, 4, 5, 6. A is equal to 1, 3, 5. B is equal to 0, 3, 4, 5. Okay. Now he is telling A union B. What is A union B? 0, 1, 3, 4, 5. Correct. 0, 1, 3, 4, 5. A union B is correct. Then he is telling A union B complement because he is going to do something with complementation. A union B complement is equal to union minus A union B. Correct. Union minus A union B. So 0, 1, 2, 3, 4, 5, 6 minus 0, 1, 3, 4, 5. So what is left? 2 is left and 6 is left. Correct. So this is also correct. 2, 6 is correct. Okay. Now, next he is telling some new thing. This is the law where it is coming. A complement. A complement is 1, 3, 5. Union minus A. That is 0, 1, 2, 3, 4, 5, 6 minus 1, 3, 5. Okay, 1, 0, 2, 4, 6. Then correct. So A complement is 0, 2, 4, 6. Same way B complement is telling again 0, 1, 2, 3, 4, 5, 6 minus B 0, 3, 4, 5. Okay. So this is gone. This is gone. 1, 2, and 6 are there. So this is also correct. B complement also 1, 2, and 6. Now very interesting. Is making an intersection of A complement and B complement. Okay. A complement intersection B complement. What are the common elements? 0 is not common. 1 is not common. Okay. 2 is common. 4 is not common. 6 is common. 2 and 6 are common. Which is correct. Which is true. Now, what is the result? A union B complement is equal to A complement intersection B complement. Okay. This is very interesting law now. Again, you see, here is union, here is intersection. Okay. Here is a total set. Okay. A union B complement is equal to A complement intersection B complement. Like that you have to do. Okay. So this is a very interesting law. What will be the other law then? You can easily tell. A intersection B complement will be what? A complement union B complement. Correct. That's all. So just inverse this. If it is coming intersection here, you put union there. If it is coming union here, you put intersection there. Here the whole will be taken complement. Here each set separate complement. Okay, that is a Demorgan's law for complementation. Let us prove that also. Now, what he did first, A union B complement he put up. Now he is going to do A intersection B. What is A intersection B? What you are getting? A intersection B. What is there? 3 is there, 5 is there. Correct. A intersection B, 3 and 5. A intersection B complement. That means union minus 3, 5. What will be the union minus 3, take away 3, take away 5. 0, 1, 2, 4, 6. Coming correctly? 0, 1, 2, 4, 6. Correct. Okay. Now is going to do A complement. We already know 0, 2, 4, 6. B complement 1, 2, 6. We already know here. Okay. Now A complement union B complement is doing now. 0, 2, 4, 6 union 1, 2, 6. Okay. So 2 and 6 are already common. So 2 and 6 are there. 0 is there. 1 is there. 2 is there. 4 and 6 is there. Okay. Now A complement union B complement is equal to 0, 1, 2, 4, 6. Now, what is the big point he is getting? A complement union B complement is equal to 0, 1, 2, 4, 6. But what he did earlier, A intersection B complement is also equal to 0, 1, 2, 4, 6. Okay. This is also equal to this. Both are equal. That means A intersection B complement is equal to A complement union B complement. Okay. So this is the other law. A intersection B, the whole complement equal to A complement union B complement. Again, very simple to remember. On the whole side, you have intersection. Okay. On the individual complement side, you have union. Okay. Whole you must put as intersection complement. And individual complement you should put and put union. Okay. If you put whole as union complement, then individual side you have to put intersection as complement. Okay. Individual complements and intersection. That's all. These are Demorgan's laws for complementation. Okay. Okay, now we are going to use Venn diagram to do something. We are going to use Venn diagrams to prove all this. So, what is the Demorgan's law for complementation? A union B, the whole complement is equal to A complement intersection B complement, and A intersection B, the whole complement is equal to A complement union B complement. Okay. Now we are going to verify the first law. A union B, the whole complement is equal to, okay, this means this equal to, this is not minus, is equal to A complement intersection B complement. Okay. How to verify that? First you have to find out A union B. What is A union B? This whole thing is A union B. This whole thing is A union B. Okay. What will be A union B complement? Everything else apart from that will be. So that is the A union B complement. So this whole thing will be this whole thing. Okay. So this whole thing becomes A union B complement. Okay. Now this is 1. LHS. This is LHS. Now let us go on to right hand side. Okay, right hand side. What is it we have to prove? A union B, A complement and B complement. You have to. What is A complement? What is? Let me speak a little low. What is A complement? A complement is everything other than A. Okay. So this whole area is A complement. Okay. What is B complement? This whole area which is other than B. Everything other than B. Okay. Everything other than B is B complement. Everything other than A is A complement. Okay. Now what you have to do? Intersection of this and that. What is the intersection of this and that? Intersection of this and that is this part alone. Okay, that part alone is the intersection, because in one thing this one comes, okay, one thing this one comes, another thing this one comes, okay, but they are coming only in one thing. What is coming common to everything is this part. Okay, so this whole thing only is A complement intersection B complement. Now, very simple, we will find that this is the same as this one. Okay, same thing. A union B complement is the same as A union B, the whole complement is the same as A complement intersection B complement. That's what you have proved by Demorgan law of complementation. You have proved now. Okay. It's 6:30. This seems to be a very big sum. Let us stop here, and we will come back again next class, and we will do the other one, because this is very big sum. You can't finish it. And exercise 1.5 also we will do it next class. Okay. Yes. Arpana, I will send you the YouTube link. Please have a look at that.
Okay, uncle. Okay,
and,
uncle.
So that you are up to date, so that you don't miss out on anything. Okay.
Yes,
Bye,
uncle.
guys. We will see you. And one more thing, guys. I have a tooth problem. Okay. And I started some treatment. First, this week I am going to treatment for reducing the swelling. Next week I will have to do some actually tooth real extraction, tooth filling and all of that. So next week I might not be able to talk completely well with you. Okay, so I am warning you beforehand. So I might be able to speak like that only. So you'll have to tolerate me next week. This week no problem, till Saturday no issues. Okay, 1 week I'm on medicines to reduce the swelling inside. My upper left teeth has got some problem. Okay, right. Thank you, guys. Bye-bye.
Okay, uncle. Take care, uncle.
Yeah, thank you. Thank you, Sandhya. Very good work today. Very fast work. Bye-bye.
Arpana left, uncle, already.
Okay. Okay. Okay, bye.
Bye.